Hello and welcome to day 2 of PyData Global 2024. Good morning, good afternoon, good evening, wherever you are in the world. We are glad that you are here with us. We're thankful for your time. And today I'm very excited to introduce KP, Kalyan Prasad, our speaker today. And Kalyan, thank you so much for your time and being part of PyData. Um, Attendees, I would encourage you to ask questions, interact with each other, interact with the speaker. You can do this by typing in the chat feature, which should be on the right-hand side of your screen. There's also a Q&A feature that you can drop questions about the last 5 minutes of the presentation. We will do some Q&A, so happy to get those answered for you if you drop them in that Q&A section. But right now, I don't want to take up any more of your time, so the floor is all yours. Thank you again for being here today, and it's all yours.
Thank you, Tomara, for the warm welcome and introduction. Hi, folks. Again, thank you for taking time and joining my session. So we have 30 minutes exactly. So again, a whole bunch of things that I have to cover in that 30 minutes. So let's get into it. So the topic that I'm going to talk about today is hidden costs of data quality, tackling common data challenges in ML. Uh, right. So let's get into some thought experiment. Since it's Christmas month, imagine that you're hosting a party, and you got a nice music and a cool setup, and also the fanciest lighting, and the food is spoiled. Yeah, it's little chaos, right? And now think of same thing in a machine learning way, right? No matter how advanced your machine learning models are, how powerful your hardware is, if your data is not up to the mark, it can be just as disastrous, right? So that's why today we are talking about most often overlooked and also the important concept called data quality. Right now, why data quality is actually important. Now, if you look at the image on the slide, right, so it basically says that no data quality, no party, and I really mean it because data is the foundation of a machine learning model. So the better the data, right, the better the quality, right, the better the outcomes are, right. So if it is like it's not well, then we are heading straight away for the disappointment, right. So that's why data quality is pretty much important. Now let's move on to something. That I think you have probably know, but may not have fully unpacked, which is garbage in and garbage out. And the concept of a GIJO is we also call it as a GIJO, right? It's widely used in data science and machine learning, right? So it basically tells that now output quality of your system example, right? Your predictions or insights com- is purely based on your input quality, right? And the three key points are, right, reliability, efficiency, trust, directly relate to the GIJO concept. So it means that unreliable data leads to unreliable results. So what we have to make sure that we have a good data quality, that improves your reliability, enhance efficiency, and also build trust in your machine learning systems. Okay. Okay, so far we talked about why data quality is important. We also understood the concept of a GIJO, right? So let's try to understand the hidden cost, or what happens when we ignore the data quality. Right. So most of the times in real time, okay, so let's stop here. So most of the times in real time, what happens is your data scientists, your machine learning engineers, or your AI engineers often focus on visible issues, like, for example, model prediction, or mm, model performances, or inaccurate predictions, right? But what about the problems which we actually don't see at the moment. So these are the hidden costs of poor data quality, and they can be as damageable as it if we if we don't focus on them, right? And one of the concept widely used in technology is called 110 and 100 uh, rule. So it basically explains the no cost of solving a problem increases the way later you catch it, right? For example, if you're trying to fixing an issue at the early stages, I mean during a development stages, it might cost you just a $1, right? If you're trying to solve the same issue, or if you find the issue during your testing phase, it might cost you $10. Or if you have discovered the issue all the way when your product is live, right, then it may cost you $100 or even more, right? So the same logic applies to your data. So if you figure out the errors during your early stages, like during your data collection or ingestion, they are very easy, and it's very less expensive to fix those issues. And if you have ignored the issue and you have discovered until your data is being processed, or your data is completely analyzed, right, then they are like very comprehensive, and it is very expensive to fix those issues in real time. Or if you have passed all the data, bad data, all the way to your end users, right, and the cost of that damage in terms of financially, and also fixing that issue is like skyrocket. It's like just boom, right? Because you are damaging the issue in terms of financially, and also the trust on the customer side, right? So there is a now so that's the reason why catching the issue and also correcting the issue as soon as possible is really important. So because it saves money, it saves time, and down the line you are not end up with issues, right? And uh, so now let's take a step back to quantify what this actually means in real terms. Uh, right. So on the graph that you are seeing a graph, right? So this is the real time graph of a poor data quality issue, right? And you can also see the percentage that describes how big impact in each of these items has. So let's try to understand one by one what's really happening behind the scenes. And if you thoroughly observe this graph, right, so the time component stands on the tall, right? So time is one of the most important crucial cost, and it arises due to invalid data in your system. So so imagine your team spending more time on messy data cleaning, organizing, and filling all those gaps, right? And it takes a lot of effort there, because so you have messed up everything, and you had to putting a lot of efforts in doing all those things. Instead, you could have used all those things in terms of building your third models, or maybe generating insights. Likewise, if you also look at the credibility part, right? So if your data is not stable, so it's very hard to believe. It's very hard to believe your results, right? So whether it can be your customers or your stakeholders or your internal team, right? Because trust definitely takes a hit. That's why it's like 65% on the graph. Added cost, right? So if you want to fix the bad data, it requires more resources, more tools, more people. Then again, so remember it again, adding cost to your existing budget, right? Then it's a huge component for an organization. Customer dissatisfaction, definitely, right? So whatever the mistake that you have made with the poor data quality, right, it will not only stays internally, so they can directly affect with your customers, so which might create frustration for them, and it also damage your reputation as well, right? And in terms of system deployment, right, so when you are dealing with a bad data quality, it will definitely slow down your projects, right? Then definitely it will delay in your system development as well. And of course, lost revenue, right? So whatever the bad decisions that you have made on the poor data quality, right, it will mislead the opportunities, it will lose your revenue, increase the cost. Overall, it is thoroughly affecting your business. Compliance issues, if you are like if you are dealing with incomplete or inaccurate data, it may lead to violence of regulations. Maybe you may lead some penal issues or some violation issues on it. And lastly, others, right? So the percentage might look a slight small number, but they are still significant issues. It can be like, reducing your team performance, or maybe slowed innovation. It can be anything. So 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 now you understood, right? So cost of hidden hidden cost of a poor data quality is not about the fixing issues. So they can affect your credibility, they can affect your finances, and they can also affect your reputation as well. So it's very important that you should have the proper data quality system in your picture. Modeling is the very easy part, but if you have a very bad if you have a very good data in place, otherwise you are like completely messing up things, and the cost will burn, the money will burn, and it's like cumbersome process for you, right? Okay, so far we have looked at the how the cost impacts the data quality and all, right? So let's try to understand the common data challenges that we might face in real time. I'm sure most of the challenges I think you have encountered while you also do in your day-to-day job if you are working in a data space, right? Missing data is like very crucial and the most important issue that we often come across in real time, right? So it means that you might have your data values have null or empty, right? And imagine that where your important information is absent, right? So the model does not have a complete picture here. So the model can only guess what's missing, but it can again lead to inaccurate predictions in real time. When it comes to outliers, there are completely extreme values that does not fit with your within your rest of your data, right? Similarly duplicate, so you might have a lot of repetitive entries in your data set that you often see in real time. Inconsistent formatting, so when your data format is not standardized, right, then it will be a little mess, especially when you are often when you are overlooking them, and it will create a trouble in your analysis. For example, think about the dates, right? So dates column, in dates column, if some dates are there like month, year, like day, month, year, or some dates are there with a month, day, and year, or it's like vice versa, right? If you have a combination of a mixed formats, then it will be a little mess if you're not standardized, or if you are not standardized the format, then it will be like trouble in your analysis as well. Again, similarly, skewed distribution means some categories or values are dominating the data sets, right? Then if you're like overlooking them, then it will be a trouble in your analysis, and you're not addressing the issues thoroughly in your data analysis part. So that is the reason why you see the quote. There is a famous quote, right? Most of the time, so we spend the data scientists spend 75 to 80% to clean the data thoroughly, right? So this is where we put a lot of efforts, right? So if you are able to do the cleaning process thoroughly, then modeling rest of the part is not a challenging thing. So this is a quite painful job, and also an important job, especially in a data science and ML space, right. Okay, now you might be wondering, so how do we practically solve these problems, right? So these are we have seen a lot of challenges, so and there are practical approaches to solve all these problems, each of these problems, right? So when it comes to missing data, right, so you can simply do with statistical methods, like for example mean, median, and mode, right? And if you want to perform some advanced techniques of imputation, you can do with a model based, or you can also delete the whole bunch of missing data if you have like domain expertise in place, right? So you know which values. So we know that I can remove the 20% of data, it doesn't matter, or it doesn't influence my model, or it doesn't influence this feature doesn't influence my model, right? So if you're strong enough, if you have strong enough knowledge on taking the call on those lines. And when it comes to outliers, right, you can keep a certain cap of range margin to address outliers, or you can perform some transformation like a log scaling to address those outliers. Duplicate entry, it doesn't make any sense to keep the duplicate entries in the data, right? So it's a straightforward process to remove all the duplicates, so that we have a clean data in place. Again, as I mentioned, formatting is really important. If you are not standardizing the formatting of your your data columns, right? So then it will confuse an analysis, and you'll end up with chaos, or you'll end up with inaccurate results eventually. Again, when it comes to skewed data, so we can balance with techniques like oversampling or smart, or you can also go with some other proper distribution to address all the skewed data distribution. I'm sure all of these might be familiar if you're working in the data space, but these are like very foundations and principles that most of the times uh, uh, we often overlooked it. And if you also look at on a high level, right, if I also talk about the numbers and a high level, right, uh, in real time, the percentage of a data quality is quite less in industries comparatively with what we do in real time. So let's say out of 100, you can see the 30% we are doing with it, accurate data quality to addressing the problem. 70% is still chaos, which means that at some point we are messing up with some of the things, right? We are not dealing things properly. So that's why this is like very key concept and quite often overlooked in real time. Now, okay, Kalyan, you talked about, okay, these things are familiar for me. I know how to deal with the missing values. I know how to apply that, the mean, median, mode, imputation techniques, or I know how to handle the outliers or skew distributions and all, right? But how do we do it, right? So this is where the tools basically comes into the picture, right? And from data manipulation to large scale data pre-processing and validation, we have a whole bunch of tools in place. And the best part is all of these tools are open source, right? And for most scenarios, as per my experience, for most scenarios, leveraging open source tools and custom workflows are pretty much enough to handle the large data sets effectively. For instance, combining pandas, dask, wax, and great expectations will allow you to clearly address the most of the data quality issues with less cost, right? Now you might be wondering, right? What about the observability platforms? So I know there are a lot of observability platforms that are also doing a great job. Of course, they are doing it. I too totally agree with that statement. But you can go for observability platforms if your organization has a budget or else willingness to invest in tools. Otherwise, a lot of these problems can definitely solve with the open source tools. All you just need to do is you just have to tailor made, you have to customize according to your needs, right? You put some extra effort to customize to according to your business needs so that you can do it. And the best part is you can also save the cost. So if you are like cost conscious, like start with the open source tools, and eventually you just go and scale it up whenever it's actually required, right? Then only go and invest in the proprietary tool. Otherwise stick to the open source. That's what like whole industries are leveraging. That's why whole industries are leveraging open source tools, and the open source ecosystem is uh, that's why it's widely used in across many industries now, right? So we are almost like in the last stage or like close stage of our presentation. So I just want to show you one of the real-time use case that how we solved or how we addressed data quality issues in one of our for one of our client. Again, so this is the issue, or this is the use case that we solved, right? How data quality transformed a marketing campaign. Since I worked with the marketing industry in the last few years, so one of the business problem that we solved is about the marketing campaign. Again again here is a quite remind like it's a quite question here. So I'm not going to reveal about the client name here because it is again a complaints. Again, I'm not going to show you the data code as well because still it's a compliance issue for me. So what I'll show you is I bought some nice visuals out of it to show you, right, how we have actually solved this whole business problem in terms of data quality, right? Right. And as I mentioned, it's a marketing segment campaign, right? It's purely based on the customer segmentations, right? So customer segmentation is basically we are trying to divide the users into distinguished groups based on their geographic behavioral, demographic, and psychographic, right? So based on this, you try to distinguish the user groups, right? And what happens when we do this process, so this will help your personalized campaign management so that you can tailor it to your respective groups. This improves your engagement, and also you get a better outcomes out of it, right? So that's what we have done here. And this was a business problem, right? So what we have done is we have launched an email marketing campaign to boost the customer engagement. Okay, that was the problem. And we have done all the data analysis here initially. Okay, we have done things, and we have also performed some ML algorithms and also some segmentation models on this use case. But we got a very poor outcomes on our campaign management, especially on the low click through rate, high unsubscribe rate, and also the poor conversion sales as well. So these were the results initially when we actually done it, right? Now we deep dived into to understand the root cause of the problem. So what we have noticed during this process is, right, so we noticed that uh, data quality issues. So we found the data quality issues, especially in the customer profiles and the transaction history, right? So and to be more precisely, what we have noticed is, so we found a 20% of missing customer emails in our missing data information, and in terms of inconsistency format, right? So what we have noticed that phone numbers and emails are we have in multiple, or it's in different formats. So that again troubled our analysis as well. And also most important thing is all the outdated data, right? So which are like inactive customers, we it has marked as a active, right? Again, that again created some trouble in our analysis, and this is how the visual looks here, right? Now, how did we address this problem, right? So we have fully focused on the data quality improvement process in the 4 different stages here. The first stage is data assessment. So what we have done is we have tried to analyze the missing data and also the inconsistencies in our data during our assessment process. Next, what we have done here is in the data cleaning process, what we have done is we have removed all the respective duplicate entries, and also we have also standardized the formats of for our phone numbers and also the email domains that we had created the trouble initially, right? So we have done that. And when it comes to enrichment part, right? So as I mentioned, there were 20% of a missing value information in our customer profiles and also in other columns, right? So what we have done is, so we have imputed all these missing values with the respective methodology based on the nature of the variables, right? Sorry, nature of the columns, and we have thoroughly addressed them. And what we have also done is for all the inactive customers, right? So we went to our CRM portals and cross checked, right, whether the customers to make sure that all the inactive customers are removed, so that there is no chaos keeping them as active in our data set. And and finally, after doing all this data analysis process, right, data cleaning and data analysis pre-processing process, right? So we have validated again. So after, so we have validated to make sure that whatever the actions we have performed, right, it's thoroughly and accurate. So we have checked how much percentage of missing values we have inputted and filled the data, and and what kind of especially the standardized formatting things, right? So we have thoroughly addressed that, so that our data is clean and ready, so that we are ready to good to push that for our modeling process. So that's what we have done. So during this process, so we have done all this cleaning, we have done pre-processing, so we got a clean data set again. Then what we have done is, so we have pushed we have pushed that data toward modeling, because we got a clean data. And this is how the visual was like. Earlier it was like this, right? Now after doing all this analysis, cleaning, and transformations, right? So we addressed all these issues thoroughly. And this was our final results of our model. So before it was right. So this is how it looks. The red graph, the red color basically shows the before fixes, and the green color basically talks about after fixes, right? So if you look at one by one, right? So the click through rate got improved from 3 to 10% because we got a better data, right? Because we have a better data in place, so that we can target the accurate segment. We can focus on accurate segmentation and target messaging to the right customers here. So all the customers received more relevant content, and also encouraging clicks for them, right? Similarly, if you also look at the conversation of sales, right, it got increased by 35 percentage because we have the high data quality in place, and which was supported by effective personalization and also compelling calls to action to driving more purchases from the clients as well. And if you also look at it, the unsubscribe rate, right, it basically got reduced by 15% because what we have done is, as emails become more relevant, so we maintain all the engagement and also reducing frustration to all the customers as well. And and the end of the day, the stakeholder trust in this data pipeline process and team has improved significantly, and we got a better results, and the client was happy, right? That's how we solve this problem. And the most important thing in data quality is you should follow some best practices in real time, especially, so these are some of the best quality or sort of best data quality practices. If you follow, or if you keep these things in the flow, right? So I think most of the issues can be solved during your initial phases, right? Especially, define and document your data quality standards. So it means that you try to set the clear completeness about set clear instructions about your completeness, consistency, and accuracy, relevant about your data information, right? So if you have the clear rules in place, then it's fine. And try to set up the automate check pipelines for your missing values, or formatting issues, or any business logic outcomes, right? So if you have just automate checks in place, then I think it's easy to catch all those things in real time. And it's also important to regularly audit your data sets to catch the anomalies or any changes in the trends, right? So it's also very important. And it's also important to collaborate with domain expertise for context aware cleaning. For example, if the use case is more specific, which requires more domain folks involvement, then it's always good to collaborate with them and take their opinions while doing certain cleaning process, right? In terms of removing columns, or in terms of removing data, or transforming data, right? So their calls definitely matters, right? And and finally, you can leverage a lot of open source frameworks to validate data pipelines. For example, Apache Airflow for consistent pipeline validation. You can do it. That's what we do. That's what we have done in our case as well. Right. So as I mentioned, right, so lot of problems can be pretty much done with open source tools. And the use case that I've shown you, right, so we have leveraged only pandas and scikit-learn to address most of the issues in our use case, because the size of the data set was medium size. And so we have the pandas and scikit. We leverage the pandas and scikit-learn, and we also have a custom scripts pipelines in place, so it was very easy for us to solve things quickly, right? Rather than going for any proprietary or any other softwares as well. So based on my experience, I think a lot of problems uh, especially on the data quality issues, can be addressed with open source tools. All you just need to have the right guides and standards in place so that you can immediately address all these quality issues, and you can build effective models and generate better outcomes, and that will significantly improve your business as well. And yeah, I think so. Yeah, if you want to explore some of the references, right, these are some of the references that you have. And lastly, yeah, that's pretty much I have from my side, and this is pretty much about me. And yeah, so if you have any questions, feedback, comments, or suggestions for me, feel free to connect with me in these platforms. I'll be happy to address any questions if you have. And yeah, thank you so much for again the opportunity to present in PyData Global. If I have time, sometime, I'll definitely take some questions. Otherwise, I can take it in Discord. I'm on time, I guess.
That's all the time we have for this session, but thank you for that. That was a really interesting presentation. I enjoyed that a lot. I think that is a wrap for our data science track today, but there's lots more talks and events throughout the schedule at PyData Global, so please do check them out. And thank you again, Kalyan, for that fantastic presentation.
Thank you.
Cool. Thank you, everyone. All the best.